Okay, so remind us then, if I do long division on this, let's just kind of remind ourselves what that process is, because what we're going to do here today is we're going to talk about dividing polynomials. We're going to do polynomial long division. So let's get all the phones away, please. If we do this using long division, we have to set it up using, remember we use this got a name, and I can't remember what it's called, but we use the division bracket, right? What goes inside?
277.
And then what goes outside?
12.
Okay, so in general, we could say the denominator goes outside, the numerator goes inside, right? Okay, so now what?
How many times is 277? And just 12 goes to 27.
Okay, so 12 doesn't go into 2, so then we scoot over a digit, and 12 goes into 27.
Twice.
How many times evenly?
Twice.
Okay, now what?
24 on the bottom.
Okay, how did I get to 24?
It
goes twice.
Okay, I multiplied. So
I subtract.
Good, so we determined how many times does 12 go into this
Twice.
number, and then once we know how many times it goes in evenly, we're gonna multiply, right, which gave us 24, and then we're going to subtract that away, right? And so we end up with 3, and I'm gonna bring down the 7, right?
3 times.
It goes in 3 times. So then we ask, how many times does 12 go into 37? And the answer is 3. Now what?
36.
Okay, so I multiply.
Subtract 36.
Good. And I subtract,
Remainder 1.
and I get what? 1. There you go. There you go. Okay, so I get 1 for my remainder. Okay, so that's how we do it. Now let's look at, you like this, huh?
Yeah, I like this.
Okay, so what's our answer then? We could say, okay, the answer, this big fraction then, is actually equal to what?
23.
Or 1.
Okay, but we don't want to say, remainder 1 doesn't really help us. What does that remainder 1 do? Well, what's it? It's a fraction. So 1/12. Okay, good. So we have a remainder of 1 that remains over the denominator, right? So we'd write that as a mixed number. We'd write it as 23 and 1/12. But really, what does a mixed number mean? A mixed number, we don't really use mixed numbers anymore. What that really means is 23 plus 1/12, right? 23 and a 12th is 23 plus an additional 1/12, right? Okay, so let's take that line of thinking and let's apply it to a polynomial. So this is the polynomial that we're going to do, right? We're going to divide this out. So we already know that we're going to put the denominator outside and the numerator inside. Okay, there's a couple things that are different about a polynomial, but it's really the same process. Okay, so the x squared plus 2x minus 5 goes outside, and this is the polynomial that goes inside. But here's something you got to be careful of. Notice that in this polynomial, we're missing the x cubed term, right? We have to include that, so we have to include a 0 coefficient there. When you put the polynomial inside the bracket, you have to, whatever the degree is, in this case 4, you have to put in all the powers of x from 4 down to the constant. And if anything's missing, you're going to add a 0, right? So this would look like 6x to the 4th plus 5x cubed plus 0x squared, because we're missing that one, plus 2x plus 8. Okay, we're going to do the same thing we did before. Now, it's not as complicated as it looks, because all we really have to focus on are the leading terms. So we're going to ask ourselves first here, how many times does the leading term x squared divide into the leading term 6x to the 4th?
X squared.
And so to find that out, we could just divide it. We could literally just set up a little division problem and say, okay, what is 6x to the 4th divided by x squared? And the answer is 6, right? 6 over 1 stays 6, but what happens to the x to the 4th over the x squared? We subtract exponents, so we get x squared, don't we? Okay, so that's going to be the first term in our answer, okay? And once again, all we did was we're just asking how many times does the leading term outside divide into the leading term inside? Now what do you suppose we do? Say it again, Gary. Well, I'm going to, not, it's easier than that. I'm going to multiply, just like we did before. If we look back at our Other problem, when we got a 2 up here, we multiplied it by 12, right? Same thing here. We're going to take this 6x squared, and we're going to multiply that. We're going to distribute it all the way through the polynomial outside, right? So what's that give us if we do that? 6x squared times x squared is 6x to the fourth. So I'm going to line it up with that column, right? What I like to do is I always ask myself, okay, what column am I going to go in? Let's do the variable first. X squared times x is x cubed. Now what's the number going to be? 6 times 1 is 6, right?
No.
X squared times, well, there's no x there, so I'm going to be in the x squared column. 6 times 1 is 6, right? Oh, sorry, 6 times, you know what, I messed up. Hang on. I messed up. Let me go back. What was I doing? I'm distributing, this was right. Okay, that gave me this, right? Now I'm going to go here, and I would get x squared times x is x cubed, but 6 times 2 is 12, right? Sorry, I skipped that one. It's all right. And then we're going to get x squared times nothing is x squared, but 6 times negative 5 is negative 30, right? See how we did that? We just distribute to the first term to get that. We distribute to the second term to get that. Distribute to the third term to get that. Okay? Now what did we do? We subtracted, right? Okay, same thing here. So we're going to subtract that whole thing. And what's that give us? Now this is where you got to be careful, because you got to remember you're always subtracting. It's easy to add. So 6x to the fourth minus 6x to the fourth, what happens?
0.
Okay, they cancel. That's what's supposed to happen. And you'll see why here in a second. What about 5x cubed? Now don't just blurt out an answer. Be careful with this. What's 5x cubed minus 12x cubed?
Negative 7x.
Okay, good. We know we're getting a number of x cubes, and 5 minus 12 is negative 7. Now in this column, I'm going to get x squareds. What is 0 minus negative 30?
Negative 30. Positive 30.
Positive 30, because when you subtract a negative, you're adding, right? So that's going to be a positive 30. And then what do I do with the other? Bring them down. Okay, good. So there's the first part of our answer. Now what do you think we do?
Repeat.
Repeat. Repeat. And what's the advantage? Well, look at the polynomial we're doing this time. It's smaller. Each time the polynomial is just going to get whittled down by one term until we're done, right? So let's look at this next one then. All right, so with the next one, now we're trying to see how many times does x squared go into negative 7x cubed, right? And so let's find out. Negative 7x cubed divided by x squared is what? Negative 7x, right? Good, we get to negative 7, and x cubed over x squared is x to the 3 minus 2. So that's going to be my next answer, or the next term in my answer, right? So I'm going to get a minus 7x. What do you think I do with the minus 7x now? Distribute. I'm going to multiply, which means I have to distribute to each term, right? So negative 7x times x squared is what?
Negative 7x cubed.
So there's my negative 7x cubed. Negative 7x times positive 2x is?
Negative 14x squared.
Good. So that's going to line up in the x squared column. And negative 7x times negative 5 is?
35x.
Okay. And then I'm just going to subtract the whole thing. Okay, so negative 7x cubed minus negative 7x cubed is? Cancels. Good. Because it's a negative, and minus a negative makes it a positive, right? Okay, so what about this one? I've got x squareds in this column. Let's look at the number. What's 30 minus negative 14?
Positive
42.
Positive 44, right?
Are you kidding me? Nobody asked for your
I won't ask for your opinion.
Oh, Master, please.
Light.
Hey, now, come on. Come on, we're all mathletes on the same team here, right? Okay, so next column, here we go. Next column, so we got x's, 2 minus 35 is what?
Negative 33.
Negative 33. And then what do I do with the 8?
Break it down.
Bring it down. Okay, so that means we go through it again, right? When do you think this process is going to end?
We get 9 we get 1 at the end.
Okay, let me ask you now, how many more steps, how many more times do you think we're going to have to go through this? Once. Once is right. How can you tell? How can you tell? Well, look at the answer, and it sometimes might even end up that would be done there, possibly. But we know that at the very most, we're only going to have to go one more time, because look at our answer. First term was x squared, next term was x, next term is going to be a constant, isn't it? Right? And then after that, all we have left over is the remainder, right? You can't go lower than the constant in a polynomial. So we're going to get a polynomial part of our answer, plus maybe a remainder, right? That's it. So we only have one more time to go through this. So now we've got to ask, how many times does x squared divide into 44x squared? So we'll just ask the question, what's 44x squared divided by x squared? And the answer is 44. Okay, everybody see that? Okay, we gotta refocus here. You can't get lost on this.
You have to distribute it to the.
So we distribute it. Good. So now we distribute the 44.
2x minus 5.
So 44 times x squared is our 44x squared. What's 44 times 2x?
88x.
Good. And what's 44 times negative 5?
Negative.
Okay, well, what is it?
220.
220. Good. How do we get that? 5 times 40 is 200. 5 times 4 is 20, right? Okay. And then we're just going to subtract, right, the whole thing. And like before, the first term cancels. If it doesn't cancel, we did something wrong, right? The first term's got to cancel. Let's see, this is going to be x's. What's negative 33 minus 88?
Negative 121.
Negative 121. And what's 8 minus negative 220?
Negative 112.
212.
212.
No,
No, it'll be 228.
228, because I'm adding 220, right? Subtracting a negative is adding, right? You can use a calculator on this if you really want to check yourself. It's fine. I'm going to do this last part in red. So we got negative 121x plus 228. Okay, can we go any further?
No.
How come? Okay, for two reasons. Because that's the constant. And also, look at this. X squared. Now, the next time we'd be asking, how many times does x squared go into 121x? Well, it doesn't, right? So we're done, right? So this is the remainder then, right? So what's our answer going to be? Let's turn this whole thing into an answer then. So our answer is going to be, this polynomial. Everybody look up here, please. We're almost done, but you got to see how to write this down, because this is the important part, right? We did all the work. This is the polynomial part. So we got 6x squared minus 7x plus 44, right? But then we got our remainder, plus our remainder. What does it remain over?
X squared plus 2x.
Yeah, right? Whatever the denominator is, just like we had before. We look back at this, we had a remainder of 1. Well, that's what remains over the 12, right? In this problem, our remainder is what remains over the denominator, right? So we're going to get, what is that?
And you like add like terms.
So that's our answer right there. Everybody see that? Yep.
Can't you add like terms?
How could I add like terms?
Because it's in the same thing. I mean, it's like.
Like, okay, are you suggesting add the 121x to that?
Yeah.
I can't, because this is part of a fraction,
I see.
right? So when we divide polynomials, we're going to get two parts to it. We're going to get a polynomial part plus some remainder that's a fraction, right? Maybe we don't get it, I mean, we might not get a remainder. If what's left over in there is a 0, then there's no remainder, right? Make sense?
Yeah.
Okay? So that's a process, right? That's a process. Now, fortunately, Fortunately, there is a little shortcut. What I think I would, no, we gotta finish this, because we gotta finish this. I'm gonna want you guys, I wanna hopefully get a little time at the end so you can practice doing this once, right?
Yeah.
But this video, I promise this video is going up today, so if you need to look at this tonight, look at it. I'm not gonna assign you very many of those, because they're big problems. In fact, I might only give you like 2 or 3 of those total. I'd make it 2, but here's the deal I'd make with you. I'll make it 2 if you just use those 2 to get enough practice. I mean, I would almost even make it 1 if you just would redo it. I'm gonna give it 2, because I want 1 with the remainder and 1 without. That's all I'll do, but if you need more practice on that assignment, what do? Redo it. Just redo the problem, right?
Yep.
Because you just gotta be ready for the test. Okay, now there is some good news to this. If we go forward, I'm gonna go through this one really quickly to give you one more look of long division, but I'm gonna show you that there's a great shortcut that goes with this time.
Let me copy it, and I'm real fast.
Okay? Okay, so I'm gonna go through this whole process really quickly. So how many times does x go into 2x to the 4th? Well, let's find out. 2x to the 4th over x is 2x cubed, right?
Yep.
So the first term is 2x cubed, all distribute. 2x cubed times x is 2x to the 4th. 2x cubed times 2 is 4x cubed. And I'm going to subtract. And the first terms cancel, and I get 3 minus 4 is negative 1x cubed. Bring down the other stuff, right? So we get a negative x squared minus x minus 8. Okay, next term. How many times does x divide into negative x cubed? I get negative x squared, right? So I'll distribute. Negative x squared times x is negative x cubed. Negative x squared times 2 is negative 2x squared, and I'll subtract. Right? First term cancels. Negative x squared minus negative 2x squared is like adding 2, right? So I'm going to get a positive x squared. Bring down the negative x, bring down the negative 8. Next term. X divides into x squared how many times? X. So I get a plus x for my next term. We'll distribute that through and get x squared plus 2x. We'll subtract. First term cancels. Negative x minus 2x is negative 3x. And then, let's see, finally, last term. Negative 3x over x equals negative 3. So negative 3 is the last part, right? We distribute that through, and we get negative 3x. Negative 3 times 2 is negative 6. We subtract, and we get a remainder of, the x's cancel, negative 8 minus negative 6 is negative 2. Right? Because remember, I'm subtracting a negative, so I'm adding. Okay, and so our answer then. Our answer looks like, this is the polynomial, right? Whoops, that's back one. Is 2x cubed minus x squared plus x minus 3. Everybody sees that, right? That's the polynomial part of my answer. Shows up right there. Plus negative 2 divided by what?
X plus 2.
X plus 2. Okay. Yes. Okay, I want to show you a really great trick here. Okay, there's the answer we got, right? Okay, look at this trick. I want to show you something really cool here. So there's this process, it's called synthetic division. And it only works when you have a linear factor on the bottom, so it can't be squared. So the first example we did couldn't do this. But in this case we can, because I'm dividing by something where the biggest power of x is 1. Right? That's what we mean by linear. Okay? Any power of x bigger than 1 and it wouldn't work. So all I have to do is I'm going to take the original polynomial and I'm going to put it into this bracket. It looks like this. I'm going to leave a little space out front for a number, then I leave room for 2 rows. Okay, the number that goes out front is going to be the 0 of the denominator. Okay, so we want to put the 0, whoops, how's that? 0 of that is what? Meaning if I set that equal to 0 and solve, what do I get? I get -2, don't I? So -2 is the value of x that makes the bottom 0. Okay, that's the number that goes in the bracket. All right, the numbers that go in the first row are just going to be the coefficients in order of the polynomial, and I have to include zeros if we're missing a term. So here we've got a 2, a 3, a -1, a -1, and a -8. Okay? And I'm going to put a box under the line in the last column. Okay? So that's how we set it up, right? That represents the division problem we're doing. Now here's how you do it. It's super easy, way, way easier than long division. All you do is to start the process off, whatever the first number is in the row on the top, the first coefficient, you just drop it all the way down below the line. Here's the rule though. Whenever a number appears below the line, you always multiply it by the number in the bracket. So 2 times -2 is what? -4. Whatever the result is, you're going to put in row 2 of the next column. So 2 times -2 is -4. Okay? Then you're going to add vertically. You add, don't subtract. You add with synthetic division instead of subtracting like regular division. So 3 plus -4 is -1. Okay, but a number appeared below, so what do we do? Multiply by -2. -1 times -2 is 2, and that goes in the second row of the next column. So we add those up. What's -1 plus 2?
1.
A number appeared. What do I do? Multiply. So what goes there?
-2.
Okay, -1 plus -2.
-3.
Number appeared.
6.
So +6. And I add, and I get -2. Okay, so I want you to tell me here if you see those numbers in your answer anyplace. Do you? What are they? Where do you see a 2 and then a -1 and then a 1 and then a -3? What are they? They're the coefficients, aren't they? Right? See, look at this 2 right here. Here's my 2. There's my -1, right? There's my +1. There's my -3. And there's my -2. How about that? So what this gives you your answer. These are the coefficients of your answer, and that's the remainder, right? So we could turn this, if we're just doing this synthetic division process, then we know that we're going to put a plus, and the -2 goes up there, right? What goes on the bottom? Well, x plus 2, whatever our denominator is, right? So on the bottom we've got x plus 2. Okay, what is this telling us then? Well, this is telling us the weakest coefficient. So what I recommend you do is you start on the right and work to the left. So that's going to be the constant, right? This is going to be the coefficient of x. That's going to be the coefficient of x cubed. If I kept going, x to the 4th, x to the 5th, etc., right? So this is saying we're going to get a -3. this is giving us a 1x plus a 1x minus an x squared, and there's our 2x cubed. That's our answer. There's the 2, there's the -1, there's the 1, there's the -3. How simple is that? Okay. There's another benefit to this. There's another benefit to this. This is kind of a 2-for-1 deal with a synthetic division. The other thing about this is, when you use synthetic division, the number that pops out in the remainder box is actually the value of the polynomial if I plug in this value, right? So you get this other thing for free that just works. And for example, let's try this. Let's say we want to know what's the value. We've got some polynomial. Let's say we've got f of x equals 2x to the 4th minus 3x squared plus 5x minus 11. And let's say we want to evaluate this polynomial at 4, okay? So if I want to try putting in 4, what am I going to get? Well, I can find out really easily by just doing synthetic division. In this case, we call it synthetic substitution. So I would use my bracket, right? What's the number that I'm plugging in? 4. What are the coefficients in order? 2.
Negative.
Up.
-3.
Nope.
5.
Nope.
3.
-11.
It would be just 3.
4.
We're doing the same process.
32.
We're gonna, so what we're doing, Gary, what we're doing here is we're just gonna do what we thought was synthetic division, and it is. But whatever shows up in the number box is gonna be the actual, what happens if we plug 4 into the function. So the remainder has dual purposes here. It tells us what the remainder is, but it also tells us what the value of the function is when I plug in that number, right? You guys are missing one. We're skipping from x to the 4th to x squared. So what's the coefficient?
0.
0, okay. We need a 0, then -3, then, okay, and then there's our remainder box. So let's do the process. You get a little practice here. What do I do first?
8.
No, first I have to drop the 2 down. I can't start until I get a number in the bottom, right? So the 2 drops down, numbers in the bottom, what do I do?
Multiply it.
Good, 2 times 4 is
8.
plus 0.
8.
Number appeared, 8 times 4 is
32.
plus -3.
29.
So 4 times 29, what's 4 times 25? 100, and that's 4 more, so 4 times 4.
106. 36.
Okay, did that right? And then add a 5, 121. 4 times 121, 4 times 100 is 400. 4 times 21 is
84.
84. Add -11, and I get what?
473.
473. So what that tells me is that f of 4 equals 473. That might seem like a lot of work, but think about this. If I had to plug that 4 in directly, I would have got some pretty big numbers, right? Because I'd be taking these exponents. I've got 2 times 4 to the 4th. 4 to the 4th is huge, right? 4 to the 4th is 216. Okay, so it's big, right? No, 256. So it's big. Then I'm starting to get really big numbers I have to work with. Right down here, I didn't have to do any of that stuff. I never had to take things to powers. All I had to do was multiply and add each time, right? So this synthetic process, yeah, it does division, which is huge. That's really useful. This isn't like amazingly useful, but it's a little bit useful. If I want to know what f of 4 is, I can use synthetic substitution and just the answers in the box. Okay? Make sense? All right, so I'm going to whittle that assignment. Well, I already made the assignment, but I didn't give you very many. I think I gave you 3 long division problems, so I think you're stuck with 3. But 2 of them are pretty easy.
Yeah, so at 473, so it's down, why won't you multiply by 4?
Because when you get here, you're done. That's the end of the process. This is the end. When you get to this is the answer box or the remainder box, right?
Because you said like when it's on the top, you don't.
Right, but there's no other column, so I'm done, right?
Oh,
Right. Okay?
Wait, Mr. Wade,
Yeah.
did you just, is 4 just like the same number?
I just made it up, yeah. I just said, what if we wanted to plug 4 into that function? Okay? Yeah. All right.
What's good?